Hello, my name is Athena, and this is my Lab 1 over charged tape. The purpose of this lab is to observe the interactions between two pieces of charged tape with each other and other objects to determine if they gained or lost electrons. The results showed that the charged pieces repelled each other and had a charge of 1.12 e to the negative 8 coulombs, and the tape was deficient of 7 e to the 10 electrons. The principles used in this lab were Newton's law, which states that force equals mass times acceleration, and was used to determine that the net force of the tape is 0. We also used Coulomb's law to determine the electric force and charge on the tape. Gravitational force was set equal to the electric force to solve for the charge. Some assumptions necessary for this lab were to assume that air resistance is negligible, the tape acts as a point charge, and the U-tape had an evenly distributed charge. In this experiment, the system is tape A and tape B, and the surroundings are everything else. For initial conditions, there were two neutral pieces of tape that were equal in length and the third piece of neutral tape that was stuck to a desk. I began by sticking tape B to the base tape and ripping it off to create a charge. Tape B was then placed near objects of different charges to determine its overall charge. Tape A was then charged in the same way as tape B, and tape B was placed near tape A until it began to float. The distance between the two pieces of tape were then measured and recorded. For my setup, the length of the tape was 0.2 meters and the mass of the tape was 2 e to the negative 4 kilograms. The distance between the two pieces of tape was 0.024 meters, and the magnitude of the gravitational force was 1.96 e to the negative 5 newtons. The magnitude of the electric force is equal to the magnitude of the gravitational force since it was floating in place. Finally, the electric charge is equal to 1.12 e to the negative 8 coulombs. I expected the two pieces of tape to repel each other, and that's exactly what they did. The U-tape was attracted to my hand, a neutral book, and a negatively charged pen, but it was repelled from another piece of U-tape. Because the momentum of tape B is not changing, we can conclude that the net Y component is 0. Tape A exerts an upward force on tape B, and the Earth exerts a downward force, which is shown in the free body diagram below. Finally, mass needs to be measured to determine the gravitational force on tape B, and that has a value of 2 e to the negative 4 kilograms. The number of atoms on the sticky surface of the tape is calculated by dividing the area of the tape, which is 1 e to the negative 20 meters squared, by the area of an atom, which is 0.004 meters squared, and this gives a value of 4 e to the 17 atoms. The ratio of number of electrons to the number of atoms is the number of electrons lost, which was calculated to be 7 e to the 10 electrons, divided by the number of atoms. This gives us 1.75 e to the negative 7 electrons per atom. In this section of the code, we calculated the charge on one piece of tape acting as a point charge. The code to calculate this is pictured to the right, and the output is displayed below. The value ended up being 1.12057 e to the negative 8 coulombs, which is close to what was previously stated as the charge. In part 2, we calculated the charge on one piece of tape acting as a line of charges. In my code, I adjusted scalars until my output visually made sense. Again, my process is pictured to the right, and the output is below. The value ended up being 1.1203 e to the negative 8 coulombs, which is even closer to what was previously stated as a charge. For the what-if question, there would be no change to the observations made with the tapes and other charged objects if the charges were switched. This is a universal physics concept, so opposite charges would still attract and like charges would still repel. For the why question, the tape is treated as a point charge in the first code and as a line charge in the second code. The second code is a more accurate representation since this is realistically how the tape is charged. The models resulted in two different values, as one was calculated as a point charge and the other as a line charge. The line charge was closer to the calculated value since it is a more accurate depiction of the real world. Some errors could have been caused by the interaction with other elements in the environment, and it's possible that the tape charges are not equal. In conclusion, since the tapes were positively charged and repelled each other, this confirms that like charges attract and opposites repel. We can see that objects can easily become slightly charged through touch. My glow script codes are placed below, and thank you for watching.